Good morning, everyone. So I've got these questions about literal equations, and as I've told you, these are equations that might not be too easy to solve or make one variable as a subject. So it needs a bit of patience, and I understand that, you don't get it yet. Okay, but hopefully when we discuss these 1, 2, 3, 4 examples here from the textbook, so these are the actual exercises that you will be answering, but there would be heaps of other ones that you can do later. All right, so let's probably have a look at this first one here. It's question 1E. So you've got there 6 multiplied by y plus 2 equals to 5 multiplied to 4 minus x. So you want x as a subject, okay? So the first thing you'd probably want to do would be to distribute the 6 to each of these terms and also the 5 to each of these terms, okay? So that you've got 6y, and then 6 times 2, you get 12, right? And then you've got 5 times 4, which is 20, and then 5 times negative x becomes minus 5x. Okay, now I can move the 20 to the left, although I would end up with a negative 5x later. So maybe what I would want to do would be to just move the minus 5x to the left side, all right? So that I have 5x, and then I have 5x here. If you do the other way around, that should be fine, but you'd end up with some negative numbers, and sometimes when you end up with an answer that's a fraction and you've got negatives there, there might be a bit of confusion as to, are you going to start with a negative or are you going to start with a positive? So with how we write algebraic expressions, we usually want to start with positives, okay? So let's just get rid of the minus 5x. We move that to the left-hand side by doing the reverse, which is adding 5x, right? So what would that be equal to? I don't like that line. Do that again. I can actually straighten that. So you've got there 5x plus 6y plus 12 equal to 20, and that just becomes 0, right? Now, what else do not belong on the left-hand side? The ones that don't belong on the left-hand side would be these two terms here, right? Because you want x by itself. So you can do it one at a time, but we can do both of them at the same time. So let's just do it both at the same time. So we minus 6y, we minus 12, okay, to do the inverse or to do the opposite, okay? And that's what we do on the other side as well. So we've got minus 6y, but then we've got there a constant, so we can write the minus 12 underneath it. So you've got minus 12 there, okay? And then again, you want to minus them too. So you've got there, these now become 0. So on the left-hand side, you're left with 5x. You've got 20 minus 12 gives you 8. 8 minus 6y, okay? Because then you just bring that minus 6y over there. Now you've got 5x. You're pretty close because then you want x by itself. You want to get rid of the 5. You divide both sides by 5. What you do on one side, you do on the other, right? To keep the balance. And therefore, you've got 8 minus 6y over 5. Okay. If you get an answer because of your manipulation there as maybe 6y minus 8 over negative 5, that should be just the same. Okay, what happens there is that this negative here, you bring that to the top, to the numerator instead. Okay, so then that becomes, let me write that here. So that becomes negative of 6y minus 8 over positive 5. So it's just putting the negative on top, right? So then that becomes negative 6y plus 8 because you're distributing the negative over 5 just to make the denominator positive, okay? And when you have that, then you've got, you can just swap the negative, the minus 6y and the plus 8 here, because you want to start your algebraic expression with a positive. So you can do that, or you can leave it as this as well. That's fine. Or a better answer would be what we have here, which is positive 8 minus 6y over 5. And that's what we've got over here as well. Okay. Let's have another example here. So again, what we want to do, we want x by itself. So if we want x by itself, we're looking at this one here, then we don't actually need to expand, right? Because we've got x by itself over here. But what we can get rid of would be this here, and therefore we can divide. So that's x times this expression. So the reverse of multiplying it by y minus 2 would be dividing it by y minus 2, and therefore you divide that by y minus 2, y minus 2, right? And therefore you can cancel these two binomials, and therefore you've got x equal to y plus 1 over y minus 2. Now this is the final answer here. You don't need to do anything there because you can't cancel the y and the y there. There's a plus operation between them. There's a minus operation between them. You can only cancel if the operation between them would be multiplication. All right. So that's the answer there. All right. Next. Now we want, again, x by itself. It's similar to question E that we solved a while ago. So you want x by itself. So this time you've got x on both sides, right? So you want to expand each of those outside the brackets. So you've got 6x plus 12 equal to 5x minus 5y, right? Now you want to have the x on one side, right? You have 5x over here. You've got 6x on the left-hand side. So the only one that you want to get rid of here would be the plus 5x. To do that, you minus 5x on both sides. Minus 5x here, minus 5x there. And therefore, you've got 6x minus 5x is x, plus 12 equal to, that becomes 0, but then you've got the minus 5y over there. Okay, now that's a plus 12. The reverse of plusing 12 is minusing 12. So you minus 12 minus 12. And therefore, that becomes 0 there. That's x equals negative 5y minus 12. Okay. It's not writing. My computer is lagging there. Okay. All right. And then the last one there, again, before you do anything, have a look at your equation first, okay? So you want, look for where your x is. There's a 2x there, there's an x there, okay? So there, again, would be x on both sides. So the first thing you want to do, expand, right? So you've got 5a minus 5 times 2x is 10x. And then you've got 9 times x is 9x, 9 times 1 is 9, right? Again, you have there the 9x and then the minus 10x here. You want to get rid of the 9x on this side. So you minus 9x on both sides. Or you could also, since this is minus 10x, you can also just get rid of the minus 10x to make it positive, right? So you can choose that. Let's see if we get a better answer over here. So we add the 10x, right, to make it positive. And then therefore you've got 5a equal to 9x plus 10x is 19x plus 9. You want to get rid of the plus 9, you minus 9 on both sides. And then you minus 9 here. And what do you have there? So you've got 5a minus 9 equals 19x. You've got 19, positive 19x there, so 19 times x. So the reverse would be to divide by 19, right? And therefore you've got 5a minus 9 over 19 is equal to x. When you have that equation there on the last, you might want to just swap them around so that your x would be on the left-hand side. So that's equal to 5a minus 9 over 19. Okay, I hope that helps. It takes a bit of practice. Take your time, be patient. Have a good day. Bye.